Question 8. Determine graphically the work done by a force from the area of force versus displacement graph. Now we know that if we are given a force displacement graph, then the area under the graph, so this is the graph right here, this is the line, this is the force with displacement. The area under the force curve is equal to the work done by that force. To find the area of a triangle, we multiply half times the base of the triangle. This is the base, symbolized by B, and this is the height, times the height, symbolized by H. If we have a rectangular area, we need to multiply the length times the width. And if we have a trapezoid, we can find its area by multiplying the height of the trapezoid times the sum of the two bases divided by 2. This is a trapezoid. We had this exercise back in class. Given that the force displacement graph is shown, what is the work done by the force on the object? Here we had two shapes. We have a rectangle and a triangle. Here he wanted to find the total work done since he didn't specify a specific displacement. So he wants you to find the total work from 0 all the way to 3 meters. That includes two areas, the area of a triangle shown here plus the area of the rectangle shown here. We found the area of the triangle, the area of the rectangle, and then we added them to find the total area, which is equal to the total work. That's another question, similar idea. Says the force is acting on the object is shown. How much is the total work done by the acting force? The total work means that you find the total area under the graph. So here we have two shapes under the line, under the curve. يعني هي المساحة المحصورة بين الخط ومحور الأكس. So here we have a rectangle and a triangle. The work done in the first period, in the first displacement from 0 to 5 is equal to the area of this rectangle, which is length times width. The length of the rectangle is 6 and its width you can see it is 5. 6 times 5, that's 30 joules. Then we have this shape right here under the graph. المساحة المحصورة بين الخط ومحور السينات. This is the shape right here. This is a triangle. Say that this is work 1. Work 2 equals to half times the base. Now how much is the base of this triangle? It is equal to 12 minus 5. The last point here is 12 and this point here is 5. So to find this length here, we will subtract 12 minus 5. 12 minus 5, that's 7. And we have the height 6. That will give you 0.5 times 12 minus 5 times 6. That's gonna give you 21 joules. So after that you find the total work by adding the two areas, 30 plus 21. That's 51. That's another question in the ministry. Obviously this shape is a trapezoid. In this question he says what is the total work done in the first 40 meters only. 40 meters, that means that that's the total displacement. So he wants you to find the total area under the curve. That's a trapezoid, so you multiply, the work is equal to the height of the trapezoid multiplied by the sum of the two bases divided by 2. Now the height of the trapezoid, you can see it is 10. This is the height of the trapezoid. it is 10 times this base right here, the bigger base, that's 40 obviously. Now the smaller base goes from 10 to 30, right? So this is 10, this is 30. You need to find the distance between 10 and 30. You'll subtract 30 minus 10, that's 20. So plus 20 divided by 2. Okay, now we multiply 20 plus 40, that's 60. 60 over 2, that's 30 times times 10, that's 300 joules. Now question B says what is the power that would be developed if the work is done in 8 seconds? Now remember that power is equal to what? Power is equal to the work divided by the time. Now we already found the work, it's 300 joules. This 300 joules of work was done in 8 seconds, so the time is 8 seconds. So that's the time. 30 or 300 over 8 is 37.5 watts. Another question here, the force displacement graph shown below represents the force applied when moving a block through a displacement of 2.4 meters. What is the work done on the block by the force? So it didn't specify a certain distance, so we are going to find the total area under the curve from 0 all the way to 2.4, the total displacement. Obviously this is a triangle, so the work is equal to the area, which is half base. The base is 2.4 and the height of the triangle is 6. So we have half times 2.4 times 6, that's going to give you a 7.2. This question we solved together in class. If the question says what is the total work done, so you need to find the total area. Here we have a triangle, here we have another triangle, here we have a rectangle and another triangle. You find the area of each one of them individually, and then you add the areas together to get the total work. If he, for example, said only during the 4 meters, only during the first 4 meters, then what you should do is you put a line. This is 4 meters. You stop here and you find the area of this triangle and the area of this triangle and add them together. If the question says only during the first 1 meter, you stop here and you only find the area of the first triangle. If the question says find the work done during the first 5 meters, during the first 5 meters, that means from 0 all the way to 5. So you stop here. You find the area of this rectangle, this triangle, and you add them together. If the question says, for example, what is the work done by the force from 4 to 5 meters? This is 4 and this is 5 meters. So you put 2 lines here and you find the area of this rectangle only, and so on. So you put a vertical line where he wants you to find the work at which distance, and you find the area under the curve. Okay,